Hello, good morning. Today we are here to study about numerical integration, that is Gaussian Quadrature 1 point, 2 point formulae and 3 point formulae, and also we are going to study the 2D integrals here. Let us start with the numerical integration. What is numerical integration? We already know numerical integration, how to solve numerical integration by conventional ways. But in FEA, what is the use of numerical integration? In finite element analysis, we already know what is the stiffness matrix. For example, for the one-dimensional element AE by L, for 1D bar element, we know the stiffness matrix, that is K is equal to AE by L 1 minus 1 minus 1 1. Okay, this is the stiffness matrix for the 1D bar element. Here we have the two nodes. Okay, if a one-dimensional element is described with the 4 number of elements, then we have 5 nodes with the 4 elements. So what is the size of the global stiffness matrix here now? 5 by 5. 5 nodes, so the size of the stiffness matrix is 5 by 5. But for n number of elements, it is not possible to find the global stiffness matrix analytically. Hence, we are using some other numerical integrations. Such a type of numerical analysis is the Gaussian Quadrature formulae. Okay. It is not the only one numerical integration method. There are some other methods are there, but it is the most used numerical integration method. Okay. Next, Gaussian Quadrature formula, we have, it is used for different polynomial equations. There are 1 point formula is there, 2 point formulae, 3 point formulae. It is depends upon the polynomial equation, the order of the polynomial equation. Which order of which equation is to be used, that depends upon the one equation is there, 2n minus 1. For example, if the function is 1 plus zeta, here we have the order of the polynomial is 1. One more equation I will write here, 1 plus zeta square. Here the order of the polynomial is 2. Okay, if you consider this equation, the order is 1. So when you are using 2n minus 1, that is equal to 1. Okay, so the value will be 2n is equal to 2, so n value is 1. If for n is equal to 1 means we are going to use 1 point formula. Similarly, when you are going to use this equation for the order of the polynomial is 3. Okay, then 2n minus 1, that is equal to 3. The highest order it is 3 here. So 2n minus 1 is equal to 3. So what is the n value here? 2n, 3 plus 1 is 4. So n value is 2. So we are going to use 2 point formula. Okay, it depends upon the order of the polynomial. So you just use 2n minus 1, 2n, I'll just clear it. You use 2n minus 1. Here you write what is the order of the equations. Okay. If the order is 3, then n will be 2. So you are going to use 2 point formula. So let us see what is 1 point formula, 2 point formula and 3 point formula. 1 point formula here, f of zeta, it is the function. Here we are using the weighting functions. For 1 point formula we are going to use only one weighting function. That value will be 2. W1 is equal to 2 and zeta value will be 0. Okay, similarly for 2-point formulae, when you are using 2-point formulae, you are using two weighting functions, w1 and w2. Okay, w1 value is 1, w2 value is 1, and you are going to use zeta 1 and zeta 2 values 1 by root 3 and 1 minus 1 by square root of 3. Similarly, 3-point formulae, we are using w1, w2, w3, three weighting functions, where w1 is 0.5555, w2 is 0.8888, w3 is 0.555. Okay, we are substituting w1, w2, w3 values are 0.55, 0.88, 0.55, where zeta 1 value is minus square root of 0.6, zeta 2 is 0, and zeta 3 is square root of 0.6. Okay, I will repeat here. 1-point formulae, weighting function, only one weighting function, that is w1, that value is 2. And the 2-point formula, we are using two weighting functions, w1 and w2. w1 is 1, w2 is 1. Similarly, for 3-point formula, we are using three weighting functions, w1, w2 and w3. w1 is minus square root of 0.6, sorry, 0.55, w2 is 0.88, w3 is 0.55. Okay, I will solve this with one problem. Okay, I will take this formula now. You already know how to solve this equation in the conventional method. The function is 1 plus r plus 2r square plus 3r cube. Okay, what is the integration of 1? That is with respect to dr, that is r. Okay, similarly integration of r is r square by 2. Similarly, integration of r square is 2r cube by 3. Integration of r cube is r raised to 4 divided by 4. Applying the upper limit, that is plus 1, lower limit is minus 1. In the finite element analysis, always the upper limit is plus 1 and lower limit is minus 1. If it is solved, the integrated value is 3.33. It is the conventional method. Now, by the finite element method, now let us see what is the equation need to be used now. What is the order here? 1 plus r plus 2r square plus 3r cube. The highest order is, the order of the polynomial equation is 3. Okay, so 2n minus 1 equal to 3, so n is equal to 2. We are using 2-point formula. In the 2-point formula, we are using two weighted functions, that is w1 and w2. w1 is 1, w2 is 1. Always it is constant. When you are going to use 2-point formula, w1 and w2 values are 1 and 1. Similarly, zeta 1 is minus 1 by square root of 3, zeta 2 is minus 1 by square root of 3. Okay, let us substitute w1, w2 and zeta 1, zeta 2 value here. What is f of zeta 1 here? F of function, this is the function. What is the function? This 1 plus r plus 2r square plus 3r cube, this is the function, where we are substituting the value of zeta 1, that is 1 divided by square root of 3. Okay, similarly f of zeta 2 means in the function, in this function f of zeta means 1 plus r plus 2r square plus 3r cube. Okay, here r is nothing but zeta. Zeta value we are 1, for the first instance we are using zeta 1, that is 1 by square root of 3. For the second instance we are putting zeta 2 value, that is minus 1 by square root of 3. Okay, substituting the value here, f of zeta 1, okay, f of zeta 1 is 2.821 and f of zeta 2 is 0.5519. You just see here, w1 is 1, w2 is 1, and f of zeta 1, in this function we are applying the zeta 1 value, that is 1 by square root of 3. Okay, So f of zeta 1 is 2.82, f of